1943, Long Island Air Base. Test pilot Mike Johnson climbed into the cockpit while the ground crew whispered below. The P-47 Thunderbolt's nose had a strange propeller, 4 blades, thicker than normal, a design no one had seen before. "This plane won't fly," said one technician. "That propeller is too heavy, too complex. The engine can't even lift it." When Mike started the engine, the propeller made an unusual sound. Deep, powerful, smooth. Throttle forward. The aircraft accelerated down the runway. And then something happened. Mike shouted over the radio, "My God, this thing flies like a rocket." "What did you do to it?" "Tower, what do you mean?" "Mike, normally I climb to 10,000 feet in 2 minutes. I just did it in 1 minute. And the speed, this is impossible. 100 miles faster." The ground station went silent, because everyone remembered the propeller that had been rejected as impossible. 6 months ago, an engineer named Frank Caldwell had presented it to upper management. "This propeller will change the war." The answer: "Too complex, can't be manufactured, you're dreaming." But Frank made it secretly. And now, in the sky, Mike Johnson was flying history's fastest fighter. There was no such thing as impossible, only ideas that hadn't been tried yet. Frank Caldwell had spent his entire career making things spin. Turbines, generators, airplane propellers, anything that turned mechanical energy into motion. By 1940, he was chief engineer at Hamilton Standard Propeller Division in Hartford, Connecticut, and he had a problem that kept him awake at night. American fighter planes were getting more powerful engines. The new Pratt & Whitney R-2800 Double Wasp produced over 2,000 horsepower. But that power was being wasted. The 3-blade propellers couldn't efficiently convert all that engine power into thrust. Pilots called it ghost power. You had 2,000 horses under the hood, but only 1,400 were actually pushing the plane forward. The other 600 were lost to inefficiency. Frank understood why. A propeller was essentially a rotating wing. Each blade had to cut through air at the perfect angle, called pitch, to generate maximum thrust. But that perfect angle changed constantly depending on airspeed, altitude, and power setting. 3-blade propellers could adjust pitch, but they had fundamental limitations. They couldn't handle the massive torque of these new engines without vibrating destructively. And they couldn't maintain efficiency across the wide range of conditions a combat aircraft experienced. The solution was mathematically clear: more blades, better pitch control, stronger construction. But implementing it was another matter entirely. Frank began designing a 4-blade propeller in early 1941, not just adding another blade to existing designs, but rethinking the entire system. Wider blade chord for better thrust. Hydraulic pitch control that could adjust each blade independently during flight. Hollow steel blades instead of solid aluminum to handle the stress. Variable pitch that could go from fine pitch for takeoff to coarse pitch for high-speed cruise. The design was elegant on paper, but Hamilton Standard's management thought it was madness. "Frank, we're about to go to war," his boss Richard told him in March 1942. "We need to manufacture thousands of propellers as quickly as possible. Your design requires precision hydraulics, specialized steel forging, and complex assembly. It's too sophisticated for wartime production." But the performance gains theoretical performance gains. "We have propellers that work right now. Good enough is better than perfect when you're trying to build an air force from scratch." Frank tried to argue with data. His calculations showed the 4-blade design would increase climb rate by 40%, boost top speed by 20%, and extend combat radius by 15%. But management wanted certainty, not calculations. They wanted proven technology that could be mass-produced by workers with minimal training. The decision was final. The project was canceled. Frank was reassigned to improve existing 3-blade designs. But Frank didn't stop. He couldn't, because he'd seen the combat reports coming from the Pacific. American pilots were getting killed because their planes couldn't climb fast enough, couldn't catch enemy fighters, couldn't escape when they needed to. The F-4F Wildcat was a tough plane, but it was slower than the Japanese Zero. The P-40 Warhawk had good firepower, but poor high-altitude performance. Even the new F-6F Hellcat, despite its powerful engine, wasn't achieving its full potential because the propeller couldn't efficiently transmit all that power. Frank knew his design could save lives. So he did what desperate engineers do. He went underground. Hamilton Standard had a small experimental shop in the back of the facility where engineers tested new concepts. Frank still had access. He started spending evenings there, using his own time and scrounged materials. He told the night shift supervisor he was working on incremental improvements to existing designs. Technically true, if you considered a complete redesign incremental. The biggest challenge was the hydraulic pitch control system. Each blade needed to rotate independently, adjusting its angle dozens of times per second based on engine RPM, airspeed, and pilot input. The mechanism had to be reliable, lightweight, and simple enough to maintain in field conditions. Frank spent 6 months just on the hydraulic system. He tested dozens of valve configurations, seal materials, and control algorithms. Most failed spectacularly, leaking hydraulic fluid, jamming under load, or responding too slowly. But each failure taught him something. By October 1942, he had a working prototype hub. Now he needed blades. The blades were the visible part of the propeller, but they were engineering marvels in their own right. Each blade had to be precisely shaped to generate thrust efficiently while withstanding enormous centrifugal forces. At full power, the tips of a spinning propeller blade experienced forces equivalent to several tons. Frank designed hollow steel blades with carefully calculated internal reinforcement. The hollow design saved weight, while the steel construction provided strength that aluminum couldn't match. Each blade was forged, machined, and balanced to tolerances of thousandths of an inch. He couldn't forge these in Hamilton Standard's main facility without authorization. So he found a small machine shop in Bridgeport run by a retired toolmaker named Jim Morrison. Jim didn't ask many questions. Frank paid cash and picked up parts personally. By January 1943, Frank had a complete propeller. 4 blades, hydraulic pitch control, the whole assembly weighing only marginally more than a conventional 3-blade unit. It sat in his experimental shop, a gleaming piece of forbidden engineering. Now he needed to test it. And for that, he needed an airplane. This is where Frank got lucky. Hamilton Standard had a contract to provide propellers for military aircraft testing. One of their liaison engineers at Republic Aviation, the company building the P-47 Thunderbolt, was an old colleague named Tom Richards. Frank called him. "Tom, I need a favor. I have an experimental propeller. I need one test flight. Just one. Unofficial." There was a long pause. "Frank, you know I can't authorize that without Dash." "I know. But this propeller could make the difference between pilots living and dying. I just need someone to try it. If it doesn't work, we forget it ever happened. If it does work, we save lives." Tom thought about it. He'd seen the combat reports too. He knew pilots were dying. One flight. Unofficial. If anyone asks, we're testing minor modifications to standard equipment. And if this goes wrong, we're both getting fired. Deal. Getting the propeller to Long Island was easy. It was labeled as standard test equipment. Installing it was trickier. Tom arranged for it to be mounted on a P-47 that was scheduled for engine performance testing. The mechanics who installed it noticed it looked different, but test aircraft always had modifications. That was the point of testing. The pilot selected for the flight was Captain Mike Johnson, an experienced test pilot who'd flown dozens of aircraft types. He was professional, detail-oriented, and, most importantly, open-minded about experimental technology. Tom briefed him the morning of the test. "We're evaluating some propeller modifications. You might notice differences in performance. We need detailed feedback." Mike walked around the P-47, examining the unusual 4-blade propeller. "This doesn't look like our standard equipment. It's experimental. Hamilton Standard wanted field testing before committing to production. Does it work? That's what you're going to tell us." Mike climbed into the cockpit at 0900 hours on February 12, 1943. The P-47 was a massive aircraft, the largest single-engine fighter in production. It needed every bit of its 2,000 horsepower just to haul its weight into the air. He started the engine. The propeller spun up smoothly. The sound was different from standard props, deeper, more authoritative. Less vibration transmitted through the airframe. Interesting. Tower cleared him for takeoff. Mike pushed the throttle forward. The P-47 accelerated down the runway faster than he expected. He rotated earlier than usual. The aircraft practically jumped off the ground. "Tower, this is Johnson. I have an unusual report." "Go ahead." "This thing climbs like nothing I've ever flown. I'm at 5,000 feet, and I've been airborne for 30 seconds. Tom Richards, listening on the ground, felt his heart rate spike. It was working. Mike continued climbing. The P-47 typically needed about 7 minutes to reach 20,000 feet. Mike got there in 4 minutes. And the aircraft was still accelerating. "Tower, I'm going to test maximum level speed." He pushed the throttle to military power and watched the airspeed indicator climb. Standard P-47s topped out around 425 miles per hour at altitude. Mike watched the needle pass 430, 440, 450, 470. It stabilized at 485 miles per hour. "Tower, confirm my airspeed indicator is working correctly. I'm showing 485 miles per hour. Stand by." Panic on the ground. They checked calibration records. The instruments were fine. Tom grabbed the radio. "Johnson, this is Richards. Your instruments are correct. How does the aircraft feel?" "Smooth. Responsive. I have more power available than I know what to do with. Whatever you did to this propeller, it's working." Tom looked at Frank, who'd been listening from a corner of the tower. Frank's hands were shaking. Not from fear, but from vindication. His impossible design worked. Over the next 2 hours, Mike put the P-47 through every test he could think of. Steep climbs, high-speed dives, combat maneuvers. The performance was consistently 20 to 30% better than standard aircraft. And the engine ran cooler because it wasn't straining against an inefficient propeller. After landing, Mike walked directly to Tom. "What did you do? That's not a minor modification. That's a completely different aircraft." Standard doctrine against Zeros was to avoid turning fights. The Zero was more maneuverable. American fighters used their superior speed and climb rate to make slashing attacks, then escape vertically. James tried it. He dove on a Zero, fired a burst, then pulled up into a steep climb. To his shock, he climbed so fast that the pursuing Zero couldn't follow. It stalled out trying to keep up while James's Hellcat continued climbing at full power. "It was like someone had given my plane wings for the first time," he wrote in his after-action report. "I could go anywhere I wanted. The Zeros couldn't touch me." By late 1944, virtually every American fighter in frontline service used Frank's four-blade propeller design. The technology spread to other aircraft types, bombers, transports, even some Navy patrol planes. Each installation showed similar performance gains. Frank received the Medal for Merit from President Truman in 1945 for his contribution to the war effort. But he always insisted the real heroes were the pilots who trusted an impossible piece of equipment enough to bet their lives on it. After the war, Frank's propeller technology became standard across the aviation industry. Commercial aircraft, military transports, even some early helicopters used variations of his hydraulic pitch control system. The fundamental innovation, precise, variable control optimized for actual flight conditions rather than theoretical ideals, influenced aircraft design for decades. Frank retired from Hamilton Standard in 1958. He spent his later years teaching engineering at Yale, where he had one consistent message for students. Impossible just means no one's figured it out yet. Your job as an engineer isn't to accept limitations. It's to find ways around them. Standard doctrine against Zeros was to avoid turning fights. The Zero was more maneuverable. American fighters used their superior speed and climb rate to make slashing attacks, then escape vertically. James tried it. He dove on a Zero, fired a burst, then pulled up into a steep climb. To his shock, he climbed so fast that the pursuing Zero couldn't follow. It stalled out trying to keep up while James's Hellcat continued climbing at full power. "It was like someone had given my plane wings for the first time," he wrote in his after-action report. "I could go anywhere I wanted. The Zeros couldn't touch me." By late 1944, virtually every American fighter in frontline service used Frank's four-blade propeller design. The technology spread to other aircraft types, bombers, transports, even some Navy patrol planes. Each installation showed similar performance gains. Frank received the Medal for Merit from President Truman in 1945 for his contribution to the war effort. But he always insisted the real heroes were the pilots who trusted an impossible piece of equipment enough to bet their lives on it. After the war, Frank's propeller technology became standard across the aviation industry. Commercial aircraft, military transports, even some early helicopters used variations of his hydraulic pitch control system. The fundamental innovation, precise, variable control optimized for actual flight conditions rather than theoretical ideals, influenced aircraft design for decades. Frank retired from Hamilton Standard in 1958. He spent his later years teaching engineering at Yale, where he had one consistent message for students. Impossible just means no one's figured it out yet. Your job as an engineer isn't to accept limitations. It's to find ways around them. He kept a photograph on his office wall. It showed Mike Johnson standing next to the P-47 from that first test flight, pointing at the four-blade propeller with a huge grin. Underneath, Mike had written, "To Frank, thanks for making the impossible fly." Frank passed away in 1967, but his innovation lived on. Modern aircraft propellers still use variations of his hydraulic pitch control system. The principle he proved, that careful engineering could extract previously impossible performance from existing engines, became a fundamental concept in aerospace design. And every time a pilot pushes the throttle forward and feels that surge of acceleration, they're experiencing Frank Caldwell's refusal to accept impossible as an answer. The war had needed heroes. It got pilots and soldiers and sailors who fought bravely. But it also needed invisible heroes, engineers who worked in secret, risking their careers to pursue ideas everyone else had rejected. Frank was one of those heroes. He never fired a shot, never flew in combat, never saw the enemy except in reports and photographs. But he saved countless lives by making American fighters faster, higher climbing, and more survivable. He won battles that were never officially recorded. He changed the course of aerial warfare with nothing but calculations, prototypes, and stubborn determination. In the end, that test flight on February 12, 1943, the flight that wasn't supposed to happen, using a propeller that wasn't supposed to work, proving performance that wasn't supposed to be possible, became one of the most important moments in aviation history. Because sometimes the most powerful weapon isn't a gun or a bomb. Sometimes it's just a really good idea that someone refused to give up on.